everyone. Thank you for coming to my talk. My talk is about zero-downtime migration. My name is Akira. I'm a bouldering team lead at Smartnews, and sometimes write code, sometimes. By the way, I know my title is the longest title in this conference. I'm really so sorry about that. Let me try to explain more about my title. So, dealing with the legacy iOS app that supports a massive user base, then assessing the risks of the deeply rooted CocoaPods setup, then migrating it to the Swift package manager plus Tuist environment in a safe and robust way without ever disrupting the feature delivery cycle. Yes, that's all about my talk today. Thank you for coming. Actually not. I still have some content here. Today's my agenda. First, I will talk about the setup before the migration, then talk about the setup after migration. Then I will talk about the strategy of the migration. After that, I will talk about the execution based on the strategy. Also talk about rollout, then I will conclude with some takeaways here. So let me start with the setup before the migration. This is our app, Smartnews iOS app, the #1 news app with the largest user base in Japan, also available in the US market. And this app has the 14-year-old history and 500,000 more codes with mixed Swift and Objective-C, and 60 or more external libraries and 70 or more internal modules. And these external libraries and internal modules were managed by CocoaPods. Also, the workspace and the projects were generated via CocoaPods. Wait, CocoaPods. Do you know the current situation of the CocoaPods? Let me explain about that. As you may know, the CocoaPods team already announced they're in the maintenance mode in their blog. Also, the CocoaPods trunk will be read-only mode from this year's December. It means from this December, we cannot get any new version of the external libraries from the CocoaPods trunk. This is a problem. And the many new libraries also do not support CocoaPods from the beginning. And several existing libraries are also starting to drop the CocoaPods support. OK, CocoaPods. So this is a problem for us and also all other companies where they're using CocoaPods. So we decided to run away from CocoaPods soon. That we decided to start this migration from CocoaPods in last year's August. We started this project as an engineering-driven project with only 2 engineers, me and one of the most awesome engineer in our company, Ottavio. I think he's in this room also. Thank you, Ottavio, for coming today. Yay. Let me talk about the after setup, the migration. Originally, our project, we used CocoaPods as a dependency manager and a project management tool, also the host tool for some supplemental tasks. First, we tried to find alternative tool about the dependency manager. Of course, we selected Swift Package Manager, SPM, because SPM is the first-party tool for Swift development, and it was officially released in 10 years ago. It's getting stable and mature. However, some concerns remain, like the developer experience and the stability on the large Xcode project having this many number of the external libraries, and the flexibility as a host tool especially for our supplemental tasks. So we still needed to find alternative tools for remaining these 2 areas. In our case, we selected Tuist. Tuist, why? The Tuist is an open source tool to manage Xcode project. And the Tuist supports SPM to integrate external libraries, means that there's a very good combination between SPM for the external libraries and the Tuist for the remaining tasks. Also, Tuist generates Xcode project and workspace file, configuration file written in the Swift. And that Tuist has very good flexibility to customize build scripts and configurations. So this is our overview, what kind of tools we selected, SPM and the Tuist. By the way, there are some good tools, but we did not select, like Xcode Gen. Xcode Gen uses YAML to define the configuration, With Tuist, the Tuist uses Swift for the configuration file, so we can leverage compile time verification, and we can enjoy more robust maintainability. Another tools, like the Bazel or Bark 2, these two have very high learning curve and quite complex system. Actually, our team strategy is to keep the team lean and fast. So we need a bit relatively low maintenance setup. That's why we did not select these tools. But these tools are still a kind of good candidate for some other companies. Yeah, let me talk about the strategy of this migration. Roughly speaking, our strategy is like this. The multiple milestones with parallel execution by 2 engineers. Our app has this kind of layer. The first, the bottom layer, the main app layer. Then this layer using the internal modules layer, and both internal modules layer and the main app layer using the external libraries layer. The first milestone is to migrate the main app layer. So at this milestone, our goal was to generate Xcode project file via Tuist. They also confirm the feasibility of the Tuist migration at early stage. It means we still have an option to roll back to find another alternative tools in case of the failure of the migration by using the Tuist. Next milestone is actually about the external libraries migration. At this milestone, we'd like to migrate all libraries from the CocoaPods to Swift packages by checking the version compatibility of the Swift packages. And the last milestone is to migrate internal modules. Migrate all internal modules from the pod spec definition file to the Tuist manifest file definition. And this is the last step to migrate everything. So as I said, this is parallel execution by 2 engineers, because we have 2 engineers. And we wanted to utilize these 2 engineers' resource as much as possible. So we started this migration from the very bottom layer up main app layer and the very top layer, external libraries layer. Then we can ignore the working conflict each other because we still have the internal layer, internal modules layer in between them. So once main app layer migration settled down, gradually started the internal modules layer by overlapping with the external libraries layer migration. Then eventually we focused on the internal modules layer migration. One important thing for us is the zero-downtime migration. It is critical to keep both feature development and delivery going because we have 15 or more engineers and they are working on the same iOS repository and they are actively developing and delivering new features every week. How did we keep feature development going? We introduced the automated tools to convert from pod spec file to Tuist manifest file automatically. And the pod spec file still can be used as a source of the configuration until we finish the migration. I will talk these details later. Also, how did we keep the feature delivery going? We introduced some tests for migration and prepared guardrail tools to avoid and detect regressions and avoid disrupting the feature delivery. And we established the feedback loops to fail fast with minimum scope. Then let me talk about the execution based on this strategy. First, about main app layer migration. This is a setup before the migration. Actually, our Xcode project having the main app target was versioned on Git. And this Xcode project file was integrated into the Xcode workspace, which is generated by the CocoaPods. So our goal at this milestone was to achieve this, generate the main Xcode project file via Tuist and integrate it to the existing Xcode workspace. This is still generated by CocoaPods at this milestone. The other one side good effect, yes, because now project file is generated from the configuration, so no more kind of hell conflicts on the project file. Yes. So let me talk about the rough migration flow about this milestone 1. First, initialize the bare minimum Tuist project with the dummy naming, then the synced original project structure one by one, like the file references, target settings, and the build phases. Also, we did some fix and refactoring to the original project structure to make the migration smooth, like the removing unused compiler flags or fixing dangling file pointers, etc. Yeah, we had this kind of issues. At the same time, we developed a project structure comparison tool based on the open source software XCDiff. This tool outputs a side-by-side HTML diff report in CI pipeline. So in this case, we could ensure there are no regressions about the target setting before and after the migration. So yes, we could catch unsynced configurations or missynced configurations while migrating, and we could detect regressions at earlier phase. Then keep syncing the original project structure and keep validating there are no regressions. Yes, finally we could replace the Xcode project with Tuist generated one with higher confidence thanks to this kind of comparison tool. Okay, then milestone 1 is done. Now let me talk about the milestone 2, external libraries layer. We have 60 or more external libraries. And before starting actual migration, we started investigation about each library and separated into 4 cases. The first case is very easy. The SPM is already supported in the current version. The very good case, nothing to do, basically. Second case is SPM is supported in newer version. This is still OK, because just needed to update the version. The third case is a bit tricky, but still kind of OK. XC framework is distributed, while SPM is not directly supported. We just needed to integrate it as a binary target. And yeah, the last case is very tricky. The SPM is not supported, and the XC framework is also not distributed. In this case, we needed to choose either remove, fork, or embed the code. So this is the ratio of each case. Mostly OK, but some the 23% XC framework and the 10% of the XC SPM is not supported case, a bit tricky. And yeah, some difficulties we faced, for example, about the XC framework. The XC framework itself doesn't have the dependency, transitive dependency information. So sometimes we needed to figure out what kind of transitive dependencies needed and which version is required of this XC framework. So yeah, in this case, we needed to figure out them by ourselves somehow and write into our local package Swift file manually. It is so annoying task. Also, another difficulty is about the SPM not supported case. Yeah, in this case, the repository are already archived or not maintained in many cases. So as I said, we needed to choose remove or fork repository or embed the library itself into our code base. Any choices have the defined pros and cons, so we needed to choose which option we should take carefully. Also, let me talk about the hybrid approach. We adopted the hybrid integration approach to avoid big bang release of the migrated libraries at the last phase. So we gradually rolled out Swift packages via CocoaPods by using open source tool, CocoaPods SPM. So in this pod file case, the Swift rich string is declared as a dependency in pod file. But actually, this Swift rich string source code using the SPM version of the Swift rich string source code. And we also could control which SPM version of the library source code is ready or not by changing this Boolean flag. So we could gradually load out instead of the load out everything at the last phase. But some downside in this hybrid approach. Like in the worst case, the package resolving time would take doubled because Xcode tries to download the transitive dependencies again, even though the Tuist SPM already resolved that. So this is kind of trade-off, whether we should take the safer approach or the better, faster time until Xcode is ready. In our team's case, we took the safer approach by utilizing this hybrid approach. Yes, the milestone 2 is done. Let me talk about the last milestone, internal modules layer migration. So it is not realistic to migrate all internal modules one by one manually because we have 70 or more internal modules, and other engineers might keep editing existing modules configuration pod spec file, and other engineers might keep adding new modules to deliver new features. So we really wanted to let other engineers continue their development without worrying about this migration. So we developed an automated migration tool named podspec to Tuist. The functionality is very easy to guess from this name. So this tool converts podspec file to the Tuist configuration file automatically. So thanks to this, other engineers can keep editing the existing podspec file as usual. Also, they keep adding new modules with podspec file. And this newly added podspec file is also automatically converted to the Tuist version of the configuration file. This is a very rough diagram of how this tool works. And the important flow is this central flow. First, read all podspec file in each internal modules directory and pass the information of the podspec file and transform those metadata for the Tuist compatible one. Then, by using the data, generate the module.swift, the Tuist configuration file for each internal module. Then integrate them into the Xcode workspace file. This entire flow is executed repeatedly on both local machine and the CI pipeline. This is one example how this tool works on the terminal. What I want to emphasize here is this. The dependency information is also automatically mapped and converted to the Swift package version 1 from the CocoaPods version 1, like a zip to the zip pod and the UI keychain store to the UI keychain store in the Swift package version. We also developed the IPA files validation and the comparison tool to detect regressions before and after migration, like checking the dynamic frameworks differences before and after migration. This is very important because if the necessary the dynamic frameworks missing, then app would crash. Or the dynamic frameworks are unexpectedly added, then the launch time may increase. Also, another checker is the bundle files for each internal module to ensure the resource bundles difference is in between the migration. Also, check top resource files, top-level resource files, like the strings file, text file, PDF file, or font file, anything. Yes, now it's done all the migrations of all milestones. Now let me talk about the rollout. The internal rollout first. The apps menus, we have an internal app, early access app system to roll out in development features to the employees only before public releases. We leveraged this early access app a lot at each milestone to check the migrated app. By this, we could fail fast if something goes wrong before public release. One good example is that we could find a few crashes related to this migration, and we could fix it before the public release. Also, we could monitor the IPA file metadata change, like the unexpected IPA file size change, or the missing frameworks information, etc. So yeah, after testing on the internal rollout, it is time to release the migrated app to the public users. And actually, the conclusion is very simple because we prepared a bunch of the comparison tool, validation tool guardrails, and we tested it on the early access app. So yeah, totally no critical issues on the public releases. Yes, we have done the zero-downtime migration with 2 engineers. OK, thank you. Let me conclude with some takeaways, what we could learn here. The custom automation tools enables the small teams like us to migrate massive and historic apps without interrupting ongoing developing workflow. Also, the IP level validation and the project diff tools are quite essential for the enduring stability during the large-scale legacy app migration. Also, the gradual hybrid integration minimizes the deployment risks by enabling early validation of new libraries formats in the real environment. Now, although some downside there, but there's still a very good option to make the safer approach. Yeah, thank you for listening today. If you have questions, please feel free to reach out to us. Thank you so much.